Hello students, how are you all? I hope you all good. And today again we are going to discuss determinants, what are in this elementary operations, product of determinants, and textbook examples. These we are going to discuss. Before going to discuss, just close your eyes. Let's have word of prayer. God, kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Right, let's move on to the first topic, elementary operations. Alright, now we are going to discuss about elementary operations. In this elementary operations, the first point, before going to this, you should remember that order of the determinant should be n is greater than or equal to 2. Then what are the possibilities are there? The first one, it is how to represent, how to interchange those all operations. See, elementary operations means the operations which you do to simplify in the determinants. Okay, so now the first one, it is like this they given. So Ri and it is Rj is there. Okay, so these are the rows and these are the columns. Or you can say in other words, it is Ri and I also. So here I may write Ri also. The reason it is row is interchanged with here only this part you have to remember. This is called as interchanged. It means, for example, 3 4 5 4 2 1 0 3 4 is there. This is your determinant. So here row 1 is this and row 3 is this and row 2 is this, right? So now if I write R1 double arrow R2, if you write this, what is meaning of that? It is R1 is replaced in the R2 place, R2 is replaced in the R1 place. Means these both are interchanged. So here I'll write this operation meaning. So now here 4 2 1 3 4 5. You are understood now. These both are exchanged or interchanged. 0 3 4. So this is about your elementary operation number 1. Now let's move on to the elementary operation number 2. How, sir, it is going to be? So this elementary operation number 2 also same like this only, but here little change is there. So what was that? So that is nothing but if, for example, Ri is there. So this Ri tends to K into Ri. So that means what I am saying it is, so whichever the R1, R2, whatever is there in that place, it is multiplied with the K. K is a one number, any number. So let me write here. So 4, 5, 6, 1, 2, 3, 4, 2, 4, 3, 6. Okay. So now what I'll do here is, here R1, R2, R3. So now I'll write R2 tends to 2R2. So I can multiply R2 with the 2. So now here what I can write 4, 5, 6 as it is. Only this R2 multiplied to 2. 2 1s are 2, 2 2s are 4, 2 3s are 6. And next 4 3 6 as it is. You are understood? So in this way you have to do. It is same for column also. Same method here what we can do C2 and tends to 2C2 or plus C1 or here also plus R1. So whichever it is possible is that you can use. Means what I am saying it is that is your third property plus just R1. That is just like C1. So like these operations are using, that is your third operation. Such kind of operations we can call it as a elementary operations to simplify the determinants. Okay, that is about elementary operations. Let's move on to the next topic. Alright, let's move on to another one, that is product of determinants. Product of determinants. So what is this product of determinants means? So I'll take example and I'll explain in that itself. Okay, first we'll take 2 by 2 order, 3 4 1 2 into 4 5 1 1 is there. Then you already know the normal matrices multiplication, same like that only you have to do. So that is first one it is. I'll tell what is difference later. So first row, first column gives the first element. So 3 4s are 12 plus 4 1s are 4. Next 3 5s are 15 plus 4 1s are 4. Same method next. 1 4s are 4 plus 2 1s are 2. 1 5s are 5 plus 2 1s are 2. So at last what is your answer here? 16, 19, 6, 7. So this is about how you multiply the determinant with the row and column. So here first row with first column of the second determinant. But next, as it is just like multiplication of matrices. But second one, another also we can do, that is a row with row multiplication. That is the difference between this determinants and that. Okay. So row with row means 3 4s are 12 plus row with row only. Okay. 4 5s are 20. Next, first row with second one. 3 1s are 3 plus 4 1s are 4. Clear? Same method now. 1 4s are 4 plus 2 5s are 10. 1 1s are 1 plus 2 1s are 2. This is row with row. Okay, so that time what is your answer? 32, 7, 14, 3. So that is about your product of determinants. Let's move on to our actual examples of textbook. Okay, alright, let's move on to the first example. Evaluate the determinant without expansion. So without expanding that you have to do. That means you need to use some elementary operation and make these all same rows or whichever the possibilities are there or not. First one, check that is there any possibility to get as a same row. So here 49 and 172. When you check this, you check here. Here this multiply with 8, 8 6 are how much? 48. So then 49 minus 48, 1 will come. Same method now. 8 4s are 32. So you are going to get 7. So then same method, 8 1s are 2 you are going to get. That means you are going to get same these only numbers. So what I do here it is, just I want to do one operation, that is C1 tends to C C3 C1 minus 8 C3 I'll do. C1 minus 8 C3. You may do some other operation also, but I am doing this operation. Okay. So another operation what sir we need to do, that also I'll explain. So this is C1 tends to C1 minus 8 C3. So means in that C1 row, that C1 is subtracted with 8 into C3. So let me do that. Now 49 minus 8 into 6, 39 minus 4 into 8. This means here 4 into 8, okay. Next one, 10 minus 1 into 8. So then 1, 7, 2, 6, 4, 1. So now what you are going to get here? 49 minus 8 6 are 48. 39 minus 8 4s are 32. 10 minus 8. 1, 7, 2, 6, 4, 1. What is at last your final answer you are going to get now? So your final answer I am going to write here, just you can observe. So here 1, 49 minus 48 1, 39 minus 32 7, 10 minus 8 is nothing but 2. 1, 7, 2, 6, 4, 1. According to the property of determinant, if two rows are same, the total becomes as 0. So the value of determinant is 0 since R1 and R2, sorry, it is C1, C2. So you can write as C1, C2 are identical. Identical means same. Okay? Because of that reason it becomes as 0. And you may ask, sir, you said to me another way, how sir it is. Another way is simple, that is also. So here I need as 41. So what I will do here it is C2 tends to C2 plus 8C3 do. C2 plus 8C3. So then what will happen? 1 plus 6 into 8, 48. 1 plus 48 is nothing but 49, then 39, then 10. So you are going to get again two rows, two columns are equal, so that it is going to be 0. Or we can say that C1, C2 are identical, so that the determinant value is 0. So this we can represent with the delta also. That's what I was written as delta. So that is about your example number 1. I hope you all understood. Let's move on to the example number 2. Alright, next one we are going to discuss let the determinant 1, 5, b plus c, and whichever it is 3 by 3 without expansion. So without expansion means again you have to check for 0 possibilities are there or not. So how sir it is possible, and is there any common circuit that we have to remove, such kind of things. Let me solve so that you can understand how to solve this problem, okay? So this is your solution. Alright, this is solution. So first we take that 1a, 1b, 1c, b plus c, c plus a plus b. So here if I add these two, a plus b plus c, here also a plus b plus c, here also a plus b plus c, so that a plus b plus c, if I common, all becomes as 1 1 1, so that it is possible to get as 0. So that first elementary operation what I will do here, it is C3 tends to C3 plus C2. Then what will happen? 1 1 1 A B C, so that C1 C2 no changes. Then we are going to that C3 one, so A plus B plus C. Next also A B C, so that A plus B plus C. Next also A B C, so that A plus B plus C. And all A plus B plus C is common, is there? So total row plus A plus B plus C common and right front. So that is equal to what we can write, A plus B plus C as front we can write. Then 1 1 1 A B C 1 1 1. So two columns are same or identical, that is C1 and C3 are identical, so that this becomes as A plus B plus C into 0, and that is nothing but 0. Here since C1 and C3 are identical, identical means both are same. Okay, so that is about your second one. Let's move on to the third. Alright, let's move on to the third one. Evaluate the determinant without expansion. By observing this, see, when I add this all, what will happen? Plus A minus A cancel, minus B plus B, minus C plus C cancel, becomes as 0. Same method, M minus M, minus N plus N, minus P plus P cancel, 0. X minus X, minus Y plus Y, minus Z plus Z, these all cancel, becomes as 0. So that it becomes very easy. So now what I will do here is, this is your solution now. Alright, now solution. So first as it is you can write A minus B, B minus C, C minus A, M minus N, N minus P, P minus M, X minus Y, Y minus Z, Z minus X. So now what I will do here is R1 tends to R1 plus R2 plus R3. This is my operation. So when you apply this operation, what is going to be this? So apply this operation. This here you can write operation. So that is going to be good for you. So equal to, so when you add all A minus B plus B minus C plus C minus A, when you add this all, you get answer as what? 0, 0, 0. And remaining all B minus C and minus P, Y minus Z, C minus A, P minus M, Z minus X. So according to the properties of determinant, if one row is 0 or one column is 0, the total value is 0. Since R1 is equal to 0. Okay, so that is about your third problem. And if you have any doubt, you can ask here. R1 plus R2 plus R3, how it is? One example I will show here. A minus B plus B minus C plus C minus A. Plus A minus A cancel, plus C minus C plus B minus B cancel, you get as 0. Similarly, this and this also, in that way you get as 0. Okay, so that is about your third problem. Let's move on to the fourth. Let's move on to the fourth. Prove that they given this order 3 determinant, and I need to prove x minus y into y minus z into z minus x. So it is very simple. The first, always you have to try to common some of the things, and I have to find out those answers. So for that purpose, what I will do, so I do is I want x minus y. So when I do like R1 tends to R1 minus R2, then x minus y, x square minus y square. Same method, these two also I want. So only 2 it is possible, so then R2 tends to R2 minus R3. Let me check now how it is using these operations. Okay, so what we are going to write? First R1 minus R2, 1 minus 1, 0. Next x minus y, x square minus y square. Next 1 minus 1, 0, y minus z, y square minus z square, 1z square. Because only at that time two operations only we can apply. We cannot apply more than that. So after completion of this is equal to what we'll do. 0, 0, 1, x minus y into nothing is there means 1, y minus z, nothing is there means 1, then z as it is. Now x minus y. So here we can write x minus y into x plus y. Because a square minus b square means a minus b into a plus b. Same method, y minus z into y plus z square. So think that the 0 into any number, 0. So can I write this as 0 into x minus y? Yes. And 0 into y minus z? Yes, we can write. So that what I will do is only I will common those two. So from this row we will common x minus y. Okay. Then second row we will common y minus z. What is left now? 0, 1, x plus y. 0, 1, y plus z. Next, 1z square. Right? So now you can expand this first column. Because here two zeros are there, then it becomes as very easy. So finding answer is very easy, right? So according to us, what are the symbols? Symbols have you remembered to solve easily? So first one it is plus, minus, plus, minus, plus, minus, plus, minus, plus. So now where is minus, where is plus, you remember here and we can complete this. So this is equal to what we will write x minus y into y minus z. Then this determinant value, how can I will write? Just also first 0, 0 into any number 0, so it's 0. 0 into again any number 0. Right? Then third one it is 1 into whatever the left in this one, that you have to multiply and subtract, right? So 1 is that, what is symbol here? Plus. So that plus 1, here symbol will be minus because of this. Okay. 1 into y plus z, you can write y plus z. Next 1 into x plus y, 1 into x plus y, x plus y. But minus symbol according to the formula, then minus x minus y. Directly writing now. So now here any cancellation, minus y plus y get cancelled. So when these all getting cancelled, what is left? X minus y into y minus z. Zeros are not valued here, so we no need to take that, no value for that. 1 into z minus x, z minus x. Hence it is proved, I think. RHS here, and this is your LHS. So LHS you have to take, and this part not to write, okay? So you have to write LHS this, and then you have to complete this whole process. Last you need to write RHS, then hence it is proved. I hope you all understood this. So first we made these two as zeros, and then we went for the normal simplification, because here not mentioned it is expansion. Okay, so that is about your fourth one. Let's move on to the fifth. All right, let's move on to the fifth one. Without expanding, prove that b plus c, c plus a plus b, and whichever it is, this third order determinant is equal to 2 third order determinants. Okay. So first two required. For two purpose, what we need to do? Just think and you can do so that it is possible to be done. So what I will do here, the first operation. So using C1 tends to C1 plus C2 minus C3 and D. So that A and B get cancelled, C plus C, 2C you are going to get. Okay, let me check now how it is possible. So when you apply it, C1 plus C2, so B plus C plus C plus A minus C3, minus A minus B. Same method next. Q plus R plus P minus Q. Same method. Y plus C plus Z plus X minus Y. Remaining as it is C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. Right? So now minus A plus A, minus B plus B, minus P plus P, minus Q plus Q, minus Y plus Y, minus X plus X cancel. What is going to get now? 2C, 2R, 2Z, 2C, 2R, 2Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, this is A, okay, and X plus 1, right? And 2 common, because you already know that any row or any column is multiplied with K, and we can write K into delta. So you remembered, I think so. So according to that, what we can do? You can write 2 first, and remaining what is that? C or Z, C plus A, R plus P, Z plus X, A plus B, P plus Q, X plus Y. So in this way we need to write. I am going a little slowly because you have to understand. So that is about that. Then I'll rub. So I was rubbed that step and I was writing everything here. Okay. So now first part done and second part here. So now in this place still I want is what here? CRZ. So here CRZ came. Then DQY, APX I want. So for that purpose what I do is these two subtract. So A minus A, C minus B you are going to get. If I do this minus A minus B, B minus C. Okay, let's do it. Or first we need to add both. So you are going to get a C plus 2A plus B. Not required, we'll do. Let me check what is possibilities are there. So first I'll write here it is these two subtract. That is C2 tends to C2 minus C1. So what is possibility to get? 2 C or Z, C2 minus C1, C plus A minus C, because C1 is C, R plus P minus R, Z plus X minus Z, because here C2 minus C1 is our elementary operation. Next, A plus B, P plus Q, X plus Y. You can write two operations at a time also you can do. That means here you can write as C3 tends to, also you can write and you can complete. But I will do one by one, okay? So now minus C plus C, minus R plus R, minus Z plus Z cancel. So what is going to be here? So this is equal to 2 times C or Z, A, P, X, A plus B, P plus Q, X plus Y. I think APQ here, and that you can subtract again. So now that means C3 times 2, C3 minus C2. These two subtract, what you are going to do? Apply this operation. C or Z, APX, and C3 plus A plus B minus A, P plus Q minus P, X plus Y minus X. Cancellation, minus A plus A minus P plus P minus X plus X. So what is going to get? C or Z, A, P, X, and one B, Q, Y. But I want in this which method here it is. So first I need to get as APX. So for that purpose what I'll do is exchange these two. That means C1, C2, double arrow meaning it is both interchange. When you interchange what you get? APX, C or Z, BQY, right? So again next what these two near B I want, then C I want. So these two again exchange. That means C2 and C3. That means C2 and C3 both exchange. So when you exchange, what you are going to get? So you are after this you are going to get the answer as this. So that hence it is. You have to write this step at last, okay? So that is about your fifth problem. If you are not understood, you can comment on YouTube comment section so that I can help you again, okay? So that is about that, or you can comment on our HC Bafna group so that I can help you, okay? So that is about our fifth one. Let's move on to the sixth. Alright, let's move on to the sixth one. If X, Y, Z are different and real, so that means what is different and real, meaning it is X is not equal to Y is not equal to Z. In other words, X minus Y is not equal to 0, Y minus Z not equal to 0, Z minus X is also not equal to 0. The same reason it is. If it equal to 0 happen, X is equal to Y will happen. Where X is equal to Y means real and equal, but here it is what they given, real and different. So because of that reason, this need to be happens. This is just you remember. It is useful in the problem when we are solving the problem. Okay, right, let's go to the solution. So you already know the one property, that is I think third, the property number 5 says just you can extend this all. So according to that property, what we can do, according to your fifth property, X, Y, Z, X square, Y square, Z square, and here what we'll do, only 1, 1, 1 plus again separate determinant, X square, Y square, Z square, this as it is will get, and the one it is X cube, Y cube, Z cube, and this is equal to 0 they given. So after this what we can do, so here just these two rows I'll exchange. If you exchange the rows, the determinant will get the minus symbol. Have you remembered this? What is that? Delta 1 is equal to minus delta. When you change the any rows or columns. So if you interchange row with row or column with column, whichever it is, okay? So for that purpose what I do, just check carefully now. So now just I interchange these two first. So when I interchange X, Y, Z, 1, 1, 1, X square, Y square, Z square. So symbol will become minus, plus. In all the places X common, common X, and here Y common, common Y. Next Z common, common Z. Okay, for each row one letter we were common. Now here one X is common, what is left? 1. x square 1x removed x cube 1x removed x square. Same method 1y square 1z square, that is equal to 0. Again same property, this property only apply for this, and these two interchange. So then minus of minus, minus of minus, minus 1 1 1. It is not modulus, it is determinant. Determinant 1 1 1 x y z x square y square z square plus x y z 1 x x square 1 y square 1 z square is equal to 0. Now minus into minus plus, so that I'm not writing this, I'm just going to rub, because minus into minus plus. Here nothing is there, it is multiplied with 1. You observe in both this is common, so common it what is possible. This is also one property we already learned, but even common method also we can use and we can complete. So now what I get here, 1x x square 1y square 1z square common. So what is left? 1 plus xyz. So write that 1 plus xyz is equal to 0. But you already find this answer, right? What do you find this answer? This answer you already found in your problem number 5, I think. 5 or 4, I think. So you check that, okay? So what is this answer? X minus y into y minus z into z minus x. That into 1 plus x y z is equal to 0. You already know that this x minus y is not equal to 0. Here equal to 0. But according to this condition, different and real, it is not equal to 0. That's what I said. X minus y not equal to 0, y minus z not equal to 0, z minus x is not equal to 0. That is only the meaning of this. Okay? So now, this is not possible. Alright, next, this y minus z also not possible. Z minus x also not possible. Then what is possible? 1 plus x y z is equal to 0 is possible. Here plus 1 go to that side, minus 1. So x y z is equal to minus 1. Hence it is proved. To check this only, we need to prove that x y z is equal to minus 1. So proved. So this is very important problem for your examination point of view. Just prepare. Okay. So this is about your 6. Let's move on to the 7th problem. We have today's last example, the 7th one. Evaluate the determinant 1 upon a square bc, 1 upon b square ca, 1 upon c square a. So how to solve this? Alright, let's solve this. So first what I will do here, operations, you just observe carefully for easy solving purpose I am going to do now. So that is R1 tends to A. R1 tends to A, R1 I do. R2 tends to B, R2 I do. R3 tends to C, R3 I do. Then what is possible to get? Check. So total R1 multiply with E. So then what you get here? 1 upon A into A square into A, B, C. And here it is 1 upon B into B square into B, A, B, C. Next, 1 upon C into C, C square into C, A, B, C. Now, A, B, B, C, C cancel. So what is going to get? 1, 1, 1. A square into A cube, B square into B cube, C square into C cube. Now ABC, ABC, ABC. See all the places ABC is there. So according to the property, one row or one column having this. So we are into one, into one manner, right? So now ABC common. 1, 1, 1. So now here C1, column number 1, column number 2, sorry, column number 3 are identical, so that this becomes as A, B, C into 0, that is nothing but 0. Since here you can write it as C1 and C3 are identical. Identical meaning is that both are equal or same numbers having. Okay, so because of that reason it becomes as 0. Then ABC into 0 is nothing but 0. So that is about your problem number 7. So if still you have any doubts, you can comment on YouTube comment section, or you can ask me in the WhatsApp so that I can help you. Okay, may God bless you.